Hello ladies and gentlemen, welcome to your third exam review video for algebra. Today we're going to be talking about systems of equations and inequalities. Let's get started. Okay, so the first question I'm going to ask you to turn to is page 51, number 18. And this is a multiple choice question where really it's not actually testing us on how to solve a system, but more what makes a solution to a system of equations. So as we read this, it says two functions, y equals absolute value of x minus 3 and 3x plus 3y equals 27, are graphed on the same set of axes. Which statement is true about the solution to the system of equations? And as you read through, you really have to understand what does it take to be a solution to the system. Okay, in order to be a solution, what does that mean? Well, the first one says 3, 0 is a solution because it satisfies one of the equations, the first one. Second one says 9, 0 is a solution to the system because it satisfies the equation 3x plus 3y equals 27. Your third choice says 6, 3 is the solution to the system because it satisfies both equations. Okay, that's the key. It has to satisfy both equations. And so that's your answer right there. If you look at the last one, it says basically any of those 3 points are the solutions because they all satisfy at least one. No, in order to be a solution to a system, it has to work in both equations. So you might want to write yourself a note there that that's what it is required. Must work in both equations. Okay, let's move on to the next one. Okay, the next one is page 60, number 31. This is a 2-point question. It says a gardener is planting 2 types of trees. Type A is 3 feet tall and grows at a rate of 15 inches per year. Type B is 4 feet tall and grows at a rate of 10 inches per year. Algebraically determine exactly how many years it will take for these trees to be the same height. Okay, so first of all, this idea that they have to be the same height, all right, what's that getting at? Well, it's getting at them being equal. Remember, same is a word for equal in math. And so we basically, if we can write an equation for type A and for type B and set them equal to each other, then we'll be able to solve for the number of years. Okay, but there's a problem with our 2 sentences here. If you read them carefully, something should stick out to you. It starts by talking about their height in feet, but then gives us a growth rate in inches. So for both of them, we are given a starting value in feet, but a growth rate in inches. Those don't match. And so if our units do not match, we have to first stop and make them match. It doesn't matter which way you go. You can either change these 3 feet into inches or inches into feet. I think for most of us, it's more comfortable to change feet into inches. So I'm going to start with the 3 feet. And the way that we showed you how to do conversions this year is to multiply by a conversion fact that is going to, is a factor of 1 that is going to allow us to cancel out the feet and be left with inches. So the conversion fact that we know that uses feet and inches is that there's 12 inches in 1 foot. If I want to cancel out the feet, I need that to go on the bottom. So 1 foot goes on the bottom, 12 inches goes on the top. That allows me to cancel my feet, and so I'm left with 3 times 12, 36 inches. Okay, I'm going to do the same thing for the 4 feet. Again, multiply by 12 inches over 1 foot so that my feet cancel. 4 times 12 is 48 inches. Okay, so now that I have the right units of measure and they match, now I can write an equation for type A and for type B. So type A starts when you're looking at writing a linear equation, you're looking for the starting value and the rate of change. Your starting value here is 36 inches, and we are growing at a rate, so that's your slope, of 15 per year, so times x. Okay, type B was 48 inches to start and growing at a growth rate of 10 inches per year, so 10x. Now what I said is if we want them to be the same, we're going to set those two equations equal. So we're going to set A equal to B, or 36 plus 15x equal to 48 plus 10x. And now it should be a pretty simple equation to solve. We're just going to bring our x's to one side and our numbers to the other. So I'm going to subtract my 10x over. Okay, so 36 plus 5x is equal to 48. Okay, just had to move that up a bit. Now we're going to go ahead and, subtract 36 from both sides to get our numbers to the other side of the equal sign. So 5x equals 12. Divide by 5, and we get an answer of 2.4. And x, of course, was our variable here. It was 15 inches per year, or 10 inches per year. That was up here in our equation. So we know that x stood for the number of years. So this is, in fact, the number of years it will take for them to be the same height. Okay, we're going to flip over to page 62, number 33. This is the first 4-point question on this exam. Okay, and so it says Jacob and Zachary go to the movie theater and purchase refreshments for their friends. Jacob spends a total of $18.25 on 2 bags of popcorn and 3 drinks. Zachary spends a total of $27.50 on 4 bags of popcorn and 2 drinks. Write a system of equations that can be used to find the price of 1 bag of popcorn and the price of 1 drink. So our variables here are what is the cost of 1 bag of popcorn, so we're going to call that P, and the price of 1 drink, we're going to call that D. Okay, so those are what are unknown to us. And so we have to write a system that uses P and D. Well, go back in your sentences if you look at what I've underlined. So if you look at those words, you can see that the equations kind of, I say, fall right off of the sentence, right? Jacob spends a total means equals $18.25 on what? 2 bags of popcorn, so 2P, and plus 3 drinks, so 3D. Okay, then we have Zachary. So Zachary spends a total of $27.50, so equals $27.50. And what is he buying? Well, he buys 4 bags of popcorn, so 4P, and 2 drinks, so 2D. So now I have a system of equations. Remember, system means more than one, okay? So we have 2 equations that came right from our word problem there that can be used to solve for P and D, price of 1 bag of popcorn and price of 1 drink. And now, in the second part of this question, it wants us to actually use the equations to determine and state the price of a bag of popcorn and the price of a drink. So that means we have to solve the equations. Okay, so I just moved it up there a little bit, and I rewrote my equations. So if you need to pause the video and get them rewritten underneath the second part of that question. And now we're going to go ahead and we need to solve this system. So what you notice here is that all of your variables have numbers in front of them. Okay, so in front of this P there's a 2. In front of the D you have a 3. Here it's 4P and 2D. So when that happens, the easiest way to solve these is by the process of elimination. And what does that mean? That means that what we need to do is multiply one or both of the equations by a number or numbers so that we get the same number in front of one of the variables, so the same coefficient with opposite signs. So if I look here at my numbers in front of P or my numbers in front of D, I just want to choose the easiest. And because 2 and 4 are multiples of each other, okay, I think it's easiest to take and multiply this top equation by -2. Now why does that work? Because if I multiply the top equation by -2, that is going to make this term right here a -4. And then when I add that to positive 4P, they're going to cancel out. So that will meet my goal of having the same number in front of the variable P, but with opposite signs. So the key to this is that you have to multiply every term by -2. So I'm going to get -4P minus 6D equals negative 36.5. So everything gets multiplied by negative 2. The bottom equation we're going to leave alone. So I'm just going to recopy it exactly as it is underneath. Now, the key here is that in order to get rid of the p's here, okay, the operation that I would need to perform in order to eliminate those is addition. I'm adding opposites, which cancels those out. So keep that in mind as I add the next things down. Negative 6 plus 2 is negative 4d equals negative 36.5 plus 27.5 is 9. Now we just simply divide by negative 4 and we get d to be 2.25. So the cost of one drink is $2.25 and we have part of our answer. But we don't have all of our answer. We also need P. We need the price of the bag of popcorn. So to do that, we're going to take our original equation. Okay, so you can take either one. It doesn't matter. I'm just going to grab the top one. And we need to replace the D with 2.25. So 2P plus 3 times 2.25 equals 18.25. I'm just going to go ahead and multiply that, and I get 6.75. Okay, I want to subtract the 6.75 to solve for my P. So 2P is going to equal 11.5. And now I divide by 2, and I get P to equal 5.75. So now the price of popcorn is 5.75. So now I have the two things I was looking for, and I'm all done. Okay, the next one we're just going to flip over one page to page 63, and we're looking at number 34. The graph of the inequality is shown below. Well, I put it off to the side so that it all fit here. Write the inequality represented by the graph. All right, so when I have to write an inequality from a graph, the first I need to do a couple things. I want to start with my y, and I have to determine my inequality sign. So as I'm looking at this, I have two things to ask myself. Normally you ask these things to yourself when you're graphing an inequality, but now if we're writing it, we have to go the other way. We have to ask ourselves, are we shaded above or below the line? And is our line solid or dotted? So the answer to the first question is that we are shading above. This is shading above the line. Therefore, our inequality should be greater than. The next question was, is this line solid or dotted? And this line is definitely solid, so therefore we have an equal sign. In my class I say if there's more to the sign, see the inequality sign, then there's more to the line. So we also sometimes say if you see the line, then make a solid line. Okay, so those are a couple little tricks to get you to remember that. Now we need the actual linear equation part of it. Okay, what is the equation of that line? Two parts to that, slope and y-intercept. So right away I can read my y-intercept here is at negative 3. So I'm going to go ahead and write negative 3. Then I need to count my slope. My slope here is up 2, right 1. So that's a slope of positive 2 over 1. So I'm going to put plus 2 and then your x for your slope. Okay, so there's your inequality written out completely. All right, part B says, on the same set of axes, graph the inequality x plus 2y is less than 4. So in order to graph an inequality on a set of axes, we need to get y by itself. Okay, so we're going to move the x over first. Remember, to isolate the y, we have to get everything away from it to the other side of the inequality. So that's going to make 2y is less than 4 minus x. Now this one's always tricky for students. At this point we divide by 2. We're dividing in all the places. So what we're going to be left with is y is less than 4 divided by 2 is 2. But this is where students get stuck. Okay, we definitely have our minus sign. Now what you need to remember is that x divided by 2, you have to be able to read that slope. Okay, and so you have to be able to see it, which means you need to know what's the number in front of the x. Well, here in the numerator in front of the x is a 1. So I'm going to write this as 1/2 x, right? If you think about it, taking half of something is the same as dividing that thing by 2, right? Half of 10 is 5. 10 divided by 2 is 5. So it's the same idea. X divided by 2 is the same as half x. Now I can read my slope and my y-intercept. So I can tell you that my y-intercept here, my b value, is 2, and my slope is -1/2. So I can go ahead then and graph this. So I'm going to go up to +2, and I have a slope of down 1, right 2. Down 1, right 2, down 1, right 2. Or I could have gone up 1, of course, left 2. And I'm going to go ahead and draw this in. But, oops, I'm going to stop myself. Before I draw it in, I want to ask myself those two questions. Solid or dotted? Well, go back and look at your inequality for this one that we're doing, okay? This inequality sign is just going to be less than. There's no equal sign underneath, so that should be a dotted line that I'm going to connect with. All right, so I want to do a nice dotted line. And, of course, I need arrows on the end. All right, and then I need to decide if I'm shading above or below. So remember we said that this sign was less than. And the way that, the easiest way to say it is it kind of looks like a crooked L. And so L stands for less than. So that means we're going to shade below. Less than is shade under. Okay, last thing I want to do, because now I have two things on the same graph, is I want to go ahead and label what I just did. So I'm going to go ahead and label y is less than 2 minus half x. All right, so now that's all graphed. I've answered part B. Part C says, the two inequalities graphed on the same axes form a system. Oscar thinks that the point 2, 1, so this point right here that I'm highlighting in red, is in the solution set for this system of inequalities. Determine and state whether you agree with Oscar. Explain your reasoning. Okay, this is a tough one, because it does happen to be the intersection point of the two lines, but does that make it a solution to a system of inequalities? And in fact, in this case, it does not, because the inequality that we graphed in part B was just a less than. It wasn't less than or equal to, meaning that every point on this line is not a solution to this inequality, okay? It's everything underneath, but not the points on. So when you have a dotted line, the solutions are not included on that line. So what we want to say here is no, all right? And you can say something like the point is on the dotted line, therefore not a solution. Okay, so there are other ways you could have explained that, but that is pretty much the simplest, to just know that if you have a point that lies on a dotted line, it is not a solution to that inequality. Okay, the last one we're going to do is page 87, number 35. This also is a 4-point question. It says an online electronics store must sell at least $2,500 worth of printers and computers per day. Each printer costs $50 and each computer costs $500. The store can ship a maximum of 15 items per day. On the set of axes below, graph a system of inequalities that models these constraints. So if you look, first of all, we're asked to graph a system of inequalities, and that should make sense to you, because if you go back in the problem, you see words like at least and maximum. So those are words that are telling us that we are looking at inequalities, okay? Now, the thing I hate about this particular question, and they've never done it before or since, is they ask you to graph something that they never asked you to write an equation for or an inequality for. So this space here is meant to clue you in that you are supposed to write a system of inequalities and put it here, and then we take whatever we wrote and we graph it down here. So I don't like that they're not specific, but that is what the question is. All right, now when you read these, I like to tell my students to pick out the two inequality words and set those up. So we have at least 2,500. Okay, that was the first one. And we have a maximum of 15 items. So those are our two inequality words, or two inequality totals. Okay, so $2,500 at least. At least means greater than or equal to, and we want the 2,500 after that. A maximum of 15. That means only up to 15 or less than or equal to 15. Okay, now we have to decide on variables that we're going to use. Well, if you look down at your graph below, you can see that the label underneath the x-axis is number of printers, and the label next to the y-axis is number of computers. So they've kind of already determined that for us. They've already determined that we're going to say x is the number of printers, and y is the number of computers. So that's important. Use your graph and use the information around you to kind of give you hints as to what our variables are, and use those to help you set up your inequalities. Okay, so if you also look here, it told us that it was at least $2,500. So if I'm bringing dollars in on the right-hand side, I have to bring money in on the left-hand side, because X and Y don't stand for money, they stand for quantity of printers and computers. So I'm looking at, I have to tie in some money. Well, that's where these sentences come in. Each printer costs $50 and each computer costs $500. That's going to bring the money into the left-hand side. So $50 times the number of printers, X, plus $500 times the number of computers, Y. All right, the other total was 15 items. Well, computers and printers are your items here, and so if you just total those up, add those up, they have to stay under 15. Okay, now we're ready to graph these. All right, but we're not quite ready. In order to graph inequalities like we just talked about, we have to get y by itself. So we have to take each of these and kind of off to the side, get y by itself. Again, they don't give you a ton of room. So I'm going to say 50x plus 500y is greater than or equal to 2,500. Okay, so I would need to subtract the 50x. So I'd have 500y is greater than or equal to 2,500 minus 50x. And now I'd need to divide by 500. So I get y is greater than or equal to 2,500 divided by 500 is 5, minus, here would be a 10th x, or 0.1x. Either one's fine. Okay, my other inequality I'm going to put over here, x plus y. This one's much easier, less than or equal to 15. Get y by itself, you just have to subtract x. So y is less than or equal to 15 minus x. Okay, so if I look at my y-intercept, and for both of these, I have 5 and 15. So when I set up my axes, that's going to be important. Okay, so like I said, my y-intercepts here were 5 and 15. So it looks like I can definitely just count by 1 on the x and the y-axis. So 1, 2, 3, 4, we'll label 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And same thing on the y-axis. You should be doing this along with me. Okay, so we get our labels, we get our axes kind of numbered. We can number every single line, or like I did, just every 5 and put down your 5, 10, 15. Okay, so now we're ready to graph these one at a time. So the first one is the one I have over on the left. We're going to start with a y-intercept of 5, and then it has a slope of negative 1/10. Well, a slope of negative 1/10 would mean we would go down 1 and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, down 1 over 10 again. It's going to bring me all the way to the end. Okay, so I connect those points and I have a line that looks like that. And then I have to decide how I am shading. So you go back to what we talked about. If you look at this inequality symbol, it's greater than or equal to, which means I am shading above. So I just want to use nice straight lines. I don't want to scribble it in. Okay, and then I should label that inequality that I just graphed. So y is greater than or equal to 5 minus 1/10 of x. All right, now it's time to do the next one. So y is less than or equal to 15 minus x. I have a y-intercept of 15, and my slope is -1. So down 1 over 1, which is going to eventually bring me all the way down to, 15 over here. All right, so that I should be able to connect as well. Okay, and again, I need to shade. So I'm going to shade beneath because this time it's less than or equal to. So I'm shading under the line. And again, I need a label. So I'm going to put it over here. Okay, so now I have completely graphed my system of inequalities. And by graphing my two inequalities on the same graph and labeling them, I've labeled my axes. Well, they labeled the axes for me, but I also scaled my axes. Okay, so now I'm ready to answer this question. Determine a combination of printers and computers that would allow the electronics store to meet all of the constraints. Explain how you obtained your answer. So I'm going to kind of write the answer above here just so that I can still see my graph. So you can see that all of these points in here, this would be your solution zone. It's a double shaded region. Any point in that double shaded region is going to work. So I'm going to say here 5 and then up to, we'll give this point right here, which is what? 5, 1, 2, 3, 4, 5, 6, 7. So I'm going to say that would be 5 printers, 7 computers. And as far as the explanation, I'm going to say this point is in the double shaded region. Okay, so that is the explanation for how I can take that point. It's any point that's in that double shaded region. All right, thanks so much. I know this was a little bit longer, guys, but thanks for sticking with me. You can tell systems of equations can be big point questions on the exam. And so it's really important that we get good practice with them and that we know what we're doing. All right, we'll see you in class next time.